Wait, I said I'm Justin. I'm Ari. That's Justin. I can't speak. We're both seniors. I'm software lead this year. I did electronics last year. Justin is Justin. He does all the things.
I do a lot of stuff.
It's very good with the robot. So yeah, electronics basically just connecting everything together and figuring out why connections aren't working. It's pretty important.
Yeah.
So a lot of different components. Once you know what they are, it makes a lot of sense.
And also a big thing about electrical is making sure we don't get disqualified at inspections when we get our robot inspected.
It happens a lot.
Yeah.
To a lot of teams. So you got to be careful with this sort of stuff.
Yeah.
So yeah. Start with the first and most important component of the robot, the robo-RIA. Alright, first of all, let's just look at this. This is just a diagram of how you wire the robot. It's probably a little bit complicated the first time you look at it. Once you know more about it, it makes a lot more sense. We're gonna go over this diagram basically piece by piece. You're gonna learn a lot more. Yeah. There's one thing that we aren't gonna really talk about too much, which is pneumatics. Some people on our team really like pneumatics, specifically him, and they're pretty useful in very specific circumstances, but we're probably gonna try and avoid them as much as possible because they just usually turn out to be a nuisance on our robot.
Also, if you're trying to wire something and you get stuck, you can just look at this diagram. You can find it at WPILib.
Yeah, docs.wpilib.org has this entire diagram. It has way more about this. It has quite literally everything you need to know about robot building, coding it, anything. Just all amazing and great and free. We love WPILib. So let's start with the robo-RIA. It's the brains of the robot. Runs all our code. It's it has some really cool electronics on board. So do any of you guys know what an FPGA is? Okay, nobody knows what an FPGA is. So basically, an FPGA is a little chip with a bunch of logic gates on it that can be programmed to act as basically whatever architecture you want it to. So it's a lot more flexible than a standard CPU. Apparently there's 2 of them on it. I don't really know what the second one is used for, but the main one just runs all your code. It's really nice. It runs a version. Does anyone here know what Linux is? Everyone loves Linux, right? Ford, what is Linux?
Linux is a stolen use, right?
It's an operating system. Yeah. So like Windows, Mac OS, it's like another one of those. It's like what Chrome OS is based off of. Pretty helpful, pretty cool. It's modified to act as an RTOS, which is a real-time operating system, which basically just means that it can operate under very strict time constraints, which is pretty true for robotics. We've had some struggles with, our code taking too long to run. You kind of have to be careful about performance if it gets too overboard. So let's go over this really quickly. There's a nice reset button on the bottom of the robo-RIA. Very helpful. Restarts everything if you have a problem. PWM control. Has anyone here built a PC? You built a PC? Do you remember plugging in your fans?
My dad did that.
Do you remember that? Do you remember what wire you used for that?
No.
You use a PWM cable. So basically what a PWM cable does, it's power. It sends over some power, positive, ground, and it sends over basically how fast you want something to spin. So in this case, it's motors, which we don't really use PWM motors anymore. We have PWM encoders, right? Yeah, encoders still use that, which basically run the same way a fan would, but backwards. It sends the speed the encoder is rotating at. But opposite direction, I guess, goes to the robo-RIA instead of going outwards. We have this cool connection on it. Let's get a quick show of hands. Have you all seen the robot run? Did you guys notice there's a bright flashing light on it? That light connects there, the robot signal light. Pretty helpful. DIO, these guys, digital in and out. It's like if you have a limit switch, is the limit switch on, is the limit switch off? That basically helps with stuff like that. If you want to send out digital in and out. Analog. Did we use the analog for the gyroscope, or did we use a custom?
We use a custom chip on top of it.
Okay.
Yeah.
So we didn't actually use that, but if you had something that had an analog input or output, basically anything that is more than just a 1 or 0, more than a true or false. That's one way to connect it. We instead use this, which is, I think, similar to the port on the top of an Arduino, if you've ever seen that. There's like a bunch of double pin line. That's it's pretty similar to this connector, if I remember right. There's a CAN network connector, which we will explain a lot more later. It's up here. What else is on here? USB. We have an Ethernet port for networking. Do you guys all know what Ethernet is? Okay. We have a USB-A cable connector, which we connect here. It's what we use. I think we used it last year to connect a webcam. There's probably a few more things you can do with it. And a USB-B female, which you only really have to use in the worst of circumstances. If you're using this, something is really, really, really bad, as me and Simon know. So that's pretty important. You have to flash it. There's a really good guide on the WPILib website. It sucks and takes forever, but once you flash it, it's pretty nice. It's just a very easy piece of hardware to use compared to some of the other options. So let's talk about that CAN network. Do you remember that? Actually, before we do that, let's pass around a RoboRio. We have one up here. If you would like to see it, this one has some tape on it because it's used in competition. Please be very gentle with it. Don't break it. It's very expensive.
And the thing on top of it is a gyroscope.
Yeah, the thing on top of it is a gyroscope. The green and yellow is the CAN cable.
Yep. And the gray cable is
Ethernet.
Yeah. Okay.
We'll just pass that around for a second. Does anyone have any questions on what just happened? Is that all making sense so far?
Important takeaway is that
It's the brains.
the RoboRio is the brains, and all the data is submitted to it.
So while it's going around, let's start talking about CAN really quick. So CAN, we use this thing called CAN-FD. It's an evolved version of the original CAN specification, which I think was created for cars, for electronics in cars to talk to each other. And basically how it works, you have each device connect, so it starts on the RoboRio, the green and white cable you see passed around, that's where the CAN network starts. Then you plug it into the first device on your network, then you plug it into the one after that, and so on. It's a bi-directional, it ends also on the PDH, which we'll get to later, this thing. Pretty cool as well. So, for example, you'd have the RoboRio plugged into a motor, it's going to be plugged into a sensor, it's going to be plugged then to end at the PDH. And yeah, it basically knows the network is over when it hits a specific resistance, I think. The data is sent over it in little packets, so each device sends little, chunks of data over the network. It goes both ways. Everything on it has a name and unique ID. Please, when you're working on this, if you plug in a new electronic to the CAN network, check its ID before you plug it in. There's usually a way to do that. And make sure it doesn't conflict with any of the other CAN IDs on the robot, because when that happens, stuff gets really broken really fast, and that's not good. We don't want our robot to break. Now, one of the problems we ran into in the past, I think 2022 we had this, was that we had too much going over the CAN network, right? It's only one cable, it gets very, very congested, the decoding of data on the RoboRio can get slow, a bunch of other things can happen, and yeah. So when that happens, we haven't pulled it out yet. Did we use the Canivore last year? We did not use it. We have this thing called the Canivore, which basically plugs in via one of these USB ports. I guess it's another use for the USB, those ports. That's basically a second CAN network, because using just the one on the robot gets very limited. Our cables for it are yellow and green. They have a pretty nice connector. If you see yellow and green, only connect it to yellow and green. Kind of self-explanatory. Debugging CAN, so if there's a problem where the device isn't showing up, or there's a problem where two devices might have the same ID, you have to go kind of in depth. It gets really, really annoying really, really fast. We have some nice software for it. We have Phoenix Tuner 10 I think we're on now. It's very, very nice. Helps you just see everything on the network at a glance, very quick. So there's two different vendors actually of electronics that we mostly use. We use one called Rev Robotics, and Cross the Road Electronics. Yeah, they're distributed from a bunch of different places, but Phoenix Tuner is when you have to debug a, what's its name? It's when you have to debug Cross the Road Electronics, or CTRE, I'll probably call them a lot. Are the Phoenixes?
Phoenixes are.
Yeah, so the main motors we use on our drivetrain are CTRE. We don't have one here, but pretty cool. If you look at our robot drivetrain, I think it's in there. You can look after it or something. Yeah, those all you use Phoenix Tuner, and Rev Hardware Client is what you use to check up on stuff from, is that Vex? Or is that
From
Rev? Rev. So that's basically what we connect all our motor controllers to, which we will get to later. Anyone have any questions on Ken?
It's pretty complicated.
It's pretty complicated. Did anyone catch most of what I said? So like, basically you plug in, I'll just simplify it again, I guess. Plug in the Robo Rio to the first motor, you plug in the first motor to the next motor. You connect them all together. You don't go back to the Robo Rio, you connect it at the end to the power distribution thing, which Justin will talk about later.
You only connect green and yellow to green and yellow.
Only connect green and yellow to green and yellow. Everything has an ID, just take care about the ID.
Now it has to warm up again.
So yeah, we don't have anything just to work. Wi-Fi. Now, our robot, we communicate with our robot either via Ethernet or via Wi-Fi. Most of the time when we're at home, we use the Wi-Fi. When we're in the pits of a competition, like we're preparing to go up, you can't actually run your own Wi-Fi network because it interferes with the field. So when you're there, you have to use an Ethernet cable. You all know what that is, right? Okay. So, yeah, that's good. We basically, on the Robo Rio, we have, the Ethernet port plugged in there. Usually on the robot, we'll have a switch connected, or we can go directly to the Wi-Fi router, which looks like this. I have it up there. The Wi-Fi router does not power normally, though. You'll see if you look at it closely, there's like a regular power port. However, do any of you guys know what Power over Ethernet is? PoE? What is it?
It's essentially just using the Ethernet cords to get power.
Yeah,
or
basically
something.
just that.
Yes.
It's the Power over Ethernet. So how these work, this is one of our injectors. So you just plug this into there, and then you plug your Ethernet cable for the Robo Rio into the open socket. And then once you're done with that, you can just plug this into the power distribution thing, which we'll get to later. Again, Justin will have an amazing talk on that. And yeah, it's pretty good. When we're at home, each of our routers have their own Wi-Fi network, so you can connect to them via the team laptops. It gets kind of annoying because you get disconnected from the global internet. You're only on the local intranet that the robot runs. It's only inside the robot, hence the name. Yeah, that's pretty cool. You also have to flash it. That gets really, really annoying because flashing the router takes a while. It's confusing. It doesn't work all the time. It's very finicky with like what port you use. And now it's time for Justin to do some explaining.
No way. Alright. Okay, so
Actually, let's pass it around really quick. A router
yeah.
and a more used power distribution thing. So how about, Sean, you get the router first? And
Should I wait a minute or
just start passing it around, and Liam go the other way. And let's look at this thing. Actually, could I have the protection back? Was good.
Keeping it.
What?
Keeping the protection thing.
Yeah.
Okay.
You
Wanna
notice that's
start?
Ethernet in, Ethernet out. There.
Yeah, that's for like if you want power and Ethernet.
But where do we connect the power to?
Okay, so we have the power distribution hub, which is if you think the Robo Rio is the brains of the robot, the power distribution hub is more of like the heart. So technically the battery is the heart, but like whatever. It's the battery and the power distribution hub like go hand in hand. So what the battery does is it connects to these two large connectors here, and that power from the battery goes into all of these connectors. So each of these connectors is up here is a high current channel, so it can withstand up to 40 amps, and we connect all of our motors and stuff to these high power channels, and then, or high current channels, I should say, and then each of them has a fuse that we can interchange in and out, and
Few of them here.
yeah, we have a few fuses, and we have a few low power channels. These are 15 amps, like they sustain at 15 amps, and they can, when you go above 15 amps, they can distribute power at 20 amps for an instantaneous moment, but if they stay at 20 amps too long, you'll probably break the fuse, because I think in the game manual, the highest amp fuse you can put on these low current channels are 15 amps. So, and in parts of the robot, I mean of the power distribution hub, is also the CAN connections, which, as Ari said earlier, the CAN loop ends at the power distribution hub. And we also have USB-C for debugging, I think. Yeah, it says it there. And then that's about it.
Yeah, one little note. If you look very closely at this diagram here, there's this little switch that says term. If this is not set to on, the CAN network won't work. So I'd recommend setting that to on.
Set it to on.
So it ends.
Okay, we can pass this around.
Wait, who has the Wi-Fi? Okay. And
Crystal.
who has the other thing? Let's pass around this again. Also very expensive robotics electronics, but it's very cool. So
Yeah.
let's pass this
Remember,
around. Sean, if you break this, I'll
40 amps, 15 amps, CAN.
Yeah. Also,
Yeah.
this connects to the battery, but you're like never gonna have to.
Yeah,
really touch
and
it.
battery. Yeah.
Don't like if it's plugged in, then just don't ever touch it.
Okay. Next, we have motors. So they're on our drivetrain. Motors are usually everywhere on our robot. They're on our intakes. They're on our like shooters or grabbers and stuff. Yeah, motors are used basically everywhere. They're connected along the CAN network, but they're also connected along to the PDH. So when you look at a motor, they'll have green and yellow CAN wires coming out, and they'll also have black and red power cables, and those will connect to the PDH. Let's see. Oh yeah, they also have encoders. When you look at this motor right here, it's a Falcon 500. So they have encoders integrated, I think.
Yeah, they're
Yeah,
integrated. That
they
little
have-
top thing on the thing.
They have integrated encoders, which basically means that it can tell you how far it's spun. So if you turn a motor like 15 degrees, it can tell you like how much the motor actually spun. Because if you tell a motor to tell 15 degrees, it'll probably turn like 15.2 degrees.
A note for someone interested in programming, it's not action degrees, it has its own weird units,
Yeah,
so you gotta be
radians.
careful with that. So they don't even use radians, they have like Falcon units.
Okay.
So, yeah.
Okay.
Little note.
And when you add a motor to your robot, you need to add it to the CAN network, which means you have to assign an ID to it.
But does
And-
anyone remember what's special about plugging something into the CAN network? Yeah, so
Yeah.
what would you do to add it instead of just plugging it into the RoboRio?
You would plug it into another one?
Yeah.
Yes. You
Good
need
job,
to
Sean.
you need to plug a motor into another motor and then into the next device on the system. Okay. And yeah, here we have a Falcon 500. These are like the best quality motors, I think, for robotics. They're also the most expensive. So you can use two types of motors. you have brushless and brushed motors, and the difference between the two is that brushed motors have these little carbon things inside of them to like conduct electricity, and when the motor spins, the carbon brushes spit like they rub against this like metal ring, so those will wear out and they'll be like what do you call it? You need to maintain them basically, and so basically brushless motors are better because they don't have carbon brushes that you need to maintain, and they're more expensive. Yeah. So important takeaway. You need to plug the motors into our CAN network, and motors are everywhere. Okay, and this is a chart for the Falcon 500. So this is like a performance chart where you can see it has a lot of lines on it, but don't worry. What you need to pay attention to is this red dotted line here is the efficiency percentage, and you know we want a lot of efficiency. So we have efficiency to speed. So at around 5,000 RPM is the max efficiency of the motor, and then after that it just like drops.
Also, somewhat important is the peak power.
Yeah, peak power, but
Never judge a motor by the torque number put on the box. Also.
yeah, but also when you need a motor to like spin something, you usually don't really need to worry all that much about like the efficiency. So this is just here if you're really on like an edge case and you need to push your motor to its limit basically. So this is a motor controller. So usually we have our CTRE Falcon 500s with integrated motor controllers, and our other motors are from Rev Robotics, which have these external motor controllers, and you can use those external motor controllers to connect them like to the system basically, or to the robot network or intranet. And here, like most Rev motors are brushed. I think that's correct, yeah. Most Rev motors are brushed, so they're gonna be less expensive and less cool, you know?
And also, it doesn't have to be a rev branded motor to work with a SparkMax, I think. It just has to be
It has to have PWM.
as long as it has a PWM connector, it should be.
Yeah. And also it uses CAN, so when you connect a motor controller to the robot, you need to assign it an ID.
Also, just a little note for everyone's sanity. Make sure if you add a new motor, tape the ID you give it onto the motor controller.
Yeah.
It really helps just identify what's what, so you don't have to go into it and try and make it blink every time. That gets so annoying after like the first 3.
Okay. And this is the most important part probably, is that you're following all the electrical guidelines and inspection protocols. So here we go. And last year we had this guy, you know, his name, I'm not gonna name drop him, but he was really annoying while inspecting our robot, and he like nitpicked every single thing. But he did point out a good point where like one of our wires was frayed, and it could have caused like shorts in
At the
bars.
bottom, it's like the last one. Electric.
Yeah, electrical. So yeah, you can find this at the game manual. You can find it on our slideshow, which will be in the FRC drive, I think.
Yeah.
Yeah.
Yeah. If you're in the, you don't have any questions,
We need like controllers for
Basically, it has all these it holds all these values and displays and stuff. And basically, our robot has a bunch of sensors, and sometimes we need to read those sensors in real time, like during the match or while we're testing the robot. So you can see all the values from those sensors on here. So say when we have our drivetrain, we have a bunch of motors going. We need to align those motors with each other. We use the shuffleboard to see the values so that we can align the motors. What else? Am I missing anything?
Right now you can see that we have controller 0 plugged in. This is usually for the driver, is controller 0 set up. So for example, if I were Matthew last year, I would use controller 0, and Tyler last year would use controller 1.
Controller 1 is subsystem.
Controller 1 is for subsystem.
Also important thing to note, we don't want to have too many like cameras going, or else we don't have free Wi-Fi. Well, we do have free
We have
Wi-Fi.
free Wi-Fi, but it's limited.
It kind of sucks.
Free as in here, but not as in right.
Yeah. Wait, what? Okay, anyway. Yeah, cameras take up a lot of bandwidth.
Yeah.
Don't want to use too many cameras.
The robot is either on teleoperated, actually no, practice is a foreign. Just make sure the robot's on teleoperated. That's basically all you need to really have that ever set to, unless you're at a competition in which it won't let you select anything other than what it gives you. It won't be different. So then you can see here, this would show how much voltage is in the battery right there. We give you a color, give you a graph inside that little battery icon. Communications, is it connected? Robot code, is it flashed? Is it flashed with the code? Do you guys remember what keyboard shortcut and then what you type in? Does anyone remember what I said? Yes.
Who said command shift?
We said command. Noah!
No,
Okay.
bro hasn't touched like a Windows computer for so long.
Okay. Then what other tabs are in here that matter? This one kind of matters. Make sure this is on 5735. That's pretty cool. Then, before you click enable and turn on the robot and make the controls available, make sure you shout enabling. It's very important, because if you enable the robot while someone's near it, that will always end poorly, and someone will get hurt. Or either because they got hurt by the robot, or you get hurt because you turned on the robot while they were near it.
Yeah, their arms will
They
fall
might be
off.
mad.
The robot will grow arms and
Yeah.
rip their arms off.
Yeah, it likes to do that.
Unless you shout enabling, in which the robot will be scared,
Yeah.
and the person near the robot will also,
He's scared and move away
Yeah,
very
and-
respectfully and calmly.
yes, and the robot will not rip their arms
But
off.
what if I want to?
It's this.
We got a battery, just
Yeah. So it's a switch. It looks like not a switch, but it is a switch. It kind of has a red button sticking out, and when you need to turn off the button, this isn't on the slideshow. Oh, okay. When you need to turn off the robot, you click this red button.
Yeah. How about we have everyone actually practice that?
Yeah,
You guys wanna, let's pass around some power buttons.
yeah. And when you need
Let's see
to
if you
turn
guys can remember how to turn on and off a robot.
when you need to turn on the robot, when this switch is off, there's this little thing here, and you just click it down. And it will be in an accessible location. Who knows what accessible is? I don't. But you know, they define it as required to be in an accessible location. So here the switch is closed, right? And now I click the red button, and suddenly the lights stop
It's
blinking.
like a circuit. Do you
Yeah,
guys remember
no,
circuits
it
from middle school?
Most of these guys are like